Hi, I'm Mukun, and this is Wilson. We are the algorithm team.
The algorithms team acts as the brain of the robot. We split our exploration algorithm into two phases, an exploration phase and an image recognition phase. During the exploration phase, we utilize the right wall hugging algorithm to explore the map as much as possible, and if any unexplored areas remain, we employ a fastest path to these unexplored areas. Pictures are also taken during this phase after a check in our algorithm.
For our fastest path challenge, we use the A-star heuristic search algorithm to calculate the fastest path to the waypoint, followed by the fastest path from the waypoint to the goal. At the start of our development, we encountered many bugs with our algorithm. To combat this, we took turns doing pair programming. This accelerated our progress, and we managed to finish our simulator development by week 4 and our core algorithms by week 7. This is Chen Jia Hang and Maskil. They are the Arduino and hardware team.
The job of the Arduino team was to handle the robot's sensor and motor functions. This was to ensure that the robot could move accurately to traverse the maze.
This was done by implementing special functions. Robot speed was ramped up to avoid jerky movements. We also changed the PID tuning values for different movement patterns to ensure precise robot movement throughout.
A big challenge was keeping sensor readings accurate. We experimented with different configurations to optimize the hardware supply. In addition, we conducted frequent calibrations to maintain consistent performance for all leaderboards.
Next, we have Wei Xuan, Marcus, and Xiaoqing from Team RPi.
The RPi communication's main role is to ensure that messages are sent from one device to another with 100% integrity. To account for this, we established a common API during week 2.
Subsequently, we hold weekly or bi-weekly meetings with the various subgroups to ensure they follow the correct API and to integrate the communications with them. We started early to avoid miscommunications in the later stages.
While the communications were being set up, we started to collate images to use in the training of the model. By training early, we were able to test our model many times to identify areas for improvement, such as white objects being hard to detect with the current model. Thus, we could retrain our model several times to increase the accuracy of detection.
Finally, here is Li Yan and Alfredo, and they are from the Android team.
Android team is responsible to develop the main user interface to monitor the robot and its surroundings. To mimic the real communication between RPi and Android, we will use AMD tool provided by the school. Firstly, we connect the Android tablet with the device. We select the device, bond them, and connect them. When sending waypoint, we use our chat box to send the XY coordinate. After typing them, we press the send waypoint button to send it to RPi to process. After sending the waypoint, a sign will be displayed on the Android device.
During exploration, RPi will send the MDF string to the tablet. The explored part of the map will be colored differently from the initial state of the map. Grids that represents the obstacles will be in black. During exploration, RPi will send the ID, XY coordinates of the special signs, which represents the images detected while the robot is moving. So after passing the string, the signs will be displayed on the map on our Android application. For robot movement, we use simple standard keyboard movement, WASD to control our robot, W to move forward, D to rotate right, A to rotate left, and S to move backwards.
We started our development early in week 2 and worked in parallel until week 7, the week we had initially planned for our integration. Some of the biggest bottlenecks for our project were hardware related. It was heartening to see the sub-teams who were ready for integration, helping out with the hardware team to keep the project moving forward. With that, we approached our first leaderboard in week 8. However, we didn't perform due to our rushed integration, which led to a communication error, causing our robot to freeze. With that in mind, we learned from our mistakes and employed a more rigorous testing phase for our leaderboard in the week 9 and clinched 8th, 3rd, and 4th place for our exploration, fastest path, and image recognition leaderboards respectively. Finally, in week 10, we made improvements to our image taking speed and performed well in the last leaderboard. We obtained 11th place for exploration, 6th place for fastest path, and 3rd place for image recognition. Thank you for listening and have a good day from Group 33.